I'm working with a dataset. It has some numbers, like age and income, and some categories, like gender and city. I need to get this data ready for a machine learning model. This option uses STANDARDSCALER to standardize age, FUNCTIONTRANSFORMER with the natural log of 1 plus income, to handle potential zero values, to transform income, and ONEHOTENCODER to convert gender and city into numerical representations. I think it's the best option. Here, it's similar to A, but it uses the natural log of income directly. This is a problem because if someone's income is 0, the log of 0 is undefined and will crash my code. I see that it uses the correct transformation for the variables. However, it uses a string for age instead of a list, which isn't the standard way, and can be prone to errors. It's not wrong, but less clear. Again, it uses a string for age, but also incorrectly handles the inputs to the ONEHOTENCODER. The data has 4 features: age and income, numbers, and gender and city categories. I need to prepare these for a machine learning model using a special tool called makecolumntransformer. I'm trying to figure out which way is the right way to use makecolumntransformer to pre-process my data and prepare it for a machine learning model. I'm given 4 different options and I need to select the correct one. After using makecolumntransformer, I'll have a dataset where age is standardized, income is log transformed, and gender and city are one-hot encoded, all ready for machine learning. I'm using scikit-learn's _make_column_transformer to prepare my data for a machine learning model. It's a super handy tool that lets me apply different cleaning and transformation steps to different parts of my data at once. These are the number-based features in my dataset. Age represents the age of a person and income represents their annual income. I will be applying different transformations to these features. These features represent categories, not numbers. Gender could be male or female, and city represents different places where people might live. I'll need to transform these into numerical representations for my model. This is the core function I'm using for the pre-processing. It's like a master conductor that orchestrates the application of different transformations to different columns. I'm using standard scalar to make the age values have a mean of 0 and a standard deviation of 1. This is called standardization and helps many machine learning models work better. I apply a log transformation, using np. Log 1p which is log 1 plus x, to the income feature to reduce its range. It's super important to use np. Log 1p instead of just np.log because np. Log 1p handles 0 values gracefully, while np.log would cause an error. I'll use one-hot encoder to change gender and city into numerical features. For example, if gender has male and female as values, one-hot encoder will create 2 features for male and female. Each row will have a value of 1 under the corresponding column and 0 otherwise. This is called one-hot encoding. This option correctly applies the transformations: standardization to age, log transformation to income, handling zeros properly, and one-hot encoding to gender and city. I'm using lists to specify the column names for standard scalar and one-hot encoder . This is wrong because it uses np.log which will break if there are any 0 values in income. This is a less preferred option. While it might work, specifying age as a string instead of a list within standard scalar isn't the best practice. This option has 2 issues. It uses np.log which can fail with 0 values and uses an incorrect specification of columns within one-hot encoder . I'm looking for the right way to use makecolumntransformer from scikit-learn to prepare my data. I need to standardize age, log transform income, and one-hot encode gender and city. My data has 2 numerical features, age and income. I'll need to treat them differently during pre-processing. This option uses STANDARDSCALER to standardize age, FUNCTIONTRANSFORMER with log 1 plus x to safely log transform income, and ONEHOTENCODER for gender and city. It's the correct approach. I have a dataset with both numerical and categorical variables which I need to pre-process. That's why I am using makecolumntransformer. Pretty cool tool, right? I'm using makecolumntransformer to clean and prepare my data before feeding it into a machine learning model. It lets me apply different transformations to different columns. This option uses a plain log function, nplog, which will cause errors if I have any zero income values. Therefore, it's wrong. This one incorrectly applies STANDARDSCALER to age as a string instead of a list. It's not ideal. Here, I have both the previous problems, plus I incorrectly specify the column city in ONEHOTENCODER. 3 problems. Yikes. It's not a good approach. After using makecolumntransformer, I'll have a nicely prepared dataset ready for model training. My data has 2 numerical features, age and income. I'll need to treat them differently during pre-processing. I'm starting with a dataset. It includes numerical data like age and income, and categorical data like gender and city. I need to prepare this data for a machine learning model. These are the numerical columns, age and income, in my dataset. I will need to transform these using numerical techniques. These are the categorical columns, gender and city, in my dataset. I will need to convert these into numerical representations. To get my data ready, I have 3 main steps. I'll standardize age, transform income using a log function, and convert gender and city into numerical forms using one-hot encoding. I'll standardize the age column. This centers the data around a mean of 0 and gives it a standard deviation of 1. This ensures that the age values don't disproportionately impact the model. Next, I'll log transform the income column using. This is safer than a regular log because it handles 0 and negative values gracefully. Finally, I will one-hot encode the gender and city columns. This converts each categorical value into a new column with binary 0 or 1 values indicating its presence or absence. This is a super useful scikit-learn function. It lets me apply different transformations to different columns of my dataset simultaneously. That's precisely what it does. Using this, I can link specific transformation methods, like standardization or one-hot encoding, to particular columns in my dataset. This is my dataset after I've done all the transformations. Now, it's ready for use with machine learning models. With the data pre-processed, I can move forward with feeding it into my machine learning model. This is the correct solution. I use standard scalar for age, function transformer, NP. Log 1p, for income, and one-hot encoder for gender and city. I'm using lists to specify columns and the appropriate function for each. I'm selecting the right way to use make_column_transformer . I need to apply the correct transformations to each column. This section introduces the core task, preparing data using the makecolumntransformer function from the scikit-learn library. We'll learn how to apply various transformations to different columns of a dataset. It's like having a toolbox for data cleanup. The dataset we're working with contains a mix of data types. I have numerical data, age and income, and categorical data, gender and city. Think of it like a spreadsheet with different kinds of information. This line describes the columns within the dataset. I have age and income as numbers, while gender and city are categories, like male, female or New York, London. This is a function in scikit-learn. It helps me apply different pre-processing steps to different columns simultaneously. It's like an assembly line for data preparation. This is the first option showing how to use makecolumntransformer. It applies standardization to age, a log transformation to income, using log. 1 plus x, which handles zeros better than a simple log, and one hot encoding to gender and city. I think this is the correct way. This option uses NPLOG for the income transformation. This is problematic because if I have an income of 0, the log of 0 is undefined. It'll crash. Here, I'm passing the column name, age, as a string instead of a list to standardscaler. While it might work, it's not the best practice. I prefer using lists for clarity. Similar to option C, it uses a string for age, and also has the NPLOG problem. Plus, the gender and city are incorrectly passed as a tuple. After applying the transformations from the selected option, I get pre-processed data ready for machine learning. Data ready. I'm working with a dataset that includes numerical data like age and income, and categorical data like gender and city. This is the raw data I need to prepare for a machine learning model. This is a scikit-learn function. I use it to apply different data transformations to different columns of my dataset all at once, making pre-processing easier. I'll use the standard scaler to standardize the age column. This means I'll center the data around a mean of 0 and a standard deviation of 1. It's a common step to get features on a similar scale. For the income column, I'll use a log transformation with the (np) log1p function, log 1 plus x. I choose log1p because it handles zeros better than a standard log function, preventing errors. I use function transformer to apply this custom function. To deal with the categorical, gender, and city columns, I'll use one hot encoder. This converts each category into a separate binary column, 0 or 1, preparing them for the model. I'm working with a dataset that includes numerical features like age and income, and categorical features like gender and city. I need to prepare this data for a machine learning model. I'll use scikit-learn's makecolumntransformer to apply different transformations to different columns of my dataset. This lets me standardize numerical data, transform other numerical data, and one hot encode categorical data, all in one go. This transformer will center my numerical data around a mean of 0 and a standard deviation of 1. I'll use this to apply the natural logarithm plus 1 function, log1p, to my income feature. This is safer than using a plain log function because it handles 0 values gracefully. This one converts my categorical features, gender and city, into numerical representations. For example, if city has values like New York and London, it creates new columns, city_New York, and city_London, with ones and zeros indicating the city. This specifies that I want to apply a transformation, like standard scaler, to the age column. This selects the income column for a transformation, like function transformer. This indicates that I want to apply one hot encoder to both the gender and city columns. This is the correct answer. I'm applying standard scaler to age, log1p transformation to income, and one hot encoder to gender and city. I'm using the correct syntax and best practices. This is incorrect because it uses np.log, which will fail if any income values are 0. This is incorrect because it provides age as a string, not a list, to standardscaler. It's bad practice, although might sometimes work. This is incorrect. It has the same string list problem with age as option C, and also incorrectly specifies gender and city in one hot encoder.